Question number 5 of the exercise asks, is 149 a prime number? Explain how you decide. So if we are having a number, how do we decide if it's a prime number or a composite number? We define a prime number to be a number greater than 1 that has 1 and itself as a factor. Now to decide for 149, you must check, can 149 be divisible evenly by any whole number other than 149 or not? So for that, any whole number other than 149 and 1, which other whole number can it be? So in order to decide for that number, to find that number, what do? We test divisibility up to its square root. Why do we test divisibility up to its square root? Because if a number n can be divisible evenly by some number bigger than its square root, it must also be divisible by some number smaller than its square root. In here, I've taken a number n is equal to 36. The square root of 36 is equal to 6. The factors, these are the different factor pairs. The 5 factor pairs of 36 are being provided. In these factor pairs, if we see every factor greater than the square root value, which is 6, for this number 36, it's paired with factor less or equal to 6. So in here, greater than 6 factors are 36, 18, 12, 9. It is every greater factor is paired, greater factor than 6 is paired with less than or equal to 6. So we are having 1, 6, 2, 3, and 4. In here, 1 is paired with 36, 2 with 18, 3 with 12, 4 with 19, 6 with 6. So you see, this is bigger factor, this is the smaller factor. So what does this mean? This means that if a number is divisible evenly by some bigger number than its square root, it is also divisible by some number smaller than its square root. So we check divisibility up to its square root only. This way, this saves time and we don't have to test every number up to 149, because compared to 36, 149 is a very, very big number. So in here, the square root of 149 is equal to approximately equal to 12. So we check all the prime numbers less than 12. Why prime numbers and not the composite numbers? Because the composite numbers, using them, it is not going to give us any new information. All the information given to us by these prime numbers are the numbers that we require. The composite numbers are not going to give any new information. So in order to avoid any repetition, any redundancy, we skip using the composite numbers. We go for the prime numbers. And in prime numbers, 2, if you remember, 2 is an even prime number, not an odd prime number. So any number that is wholly divisible or evenly divisible by 2, that is also divisible by other composite numbers like 4, 6, 8, and 10. So that is already being checked using the prime number of 2. So therefore, the rest, we are using all the prime numbers to check the divisibility of our number n, which is 149 in here. And in all of them, as you can see, it is not giving us a whole number. Since it's not giving us a whole number, it means that 149 is a prime number. So any number, 149 in our question we had, any other number if you want to check and to decide if it's a prime number or not, we check and we test the divisibility up to its square root. Below the square root, the numbers that are below its square root, we check those prime numbers and we see the result. If it is giving us a whole number, that is a composite number. If it is not giving us a whole number, we categorize it to be a prime number. That's all for now. I hope it's clear. Happy learning.